Started a very interesting topic, which is foundation, and we learned a little bit about foundation. Next week, Monday, promise, I will show you very interesting software to design any type of foundation. We have isolated footing, just one footing for each column. If you have overlap between this column and this footing and this footing, the overlap, because the distance between or spacing between this column and this column, they are very close to each other. So if you are trying, or from your design, you design isolated footing for this one and isolated footing for that one, we have something called overlap. As you remember last time, I told you, hey, the center line of your footing should be the center line of your column. So previously, first step, you are locating your column in your architectural plan. Then you design your floor, you design your column, then design foundation. So once I design foundation, I found this footing, something like this, and the other footing, something like this. So we have overlap between two footings, so we are looking for different type of foundation called combined footing. Both of them well combined on one footing called combined footing. If your structure system not a column, it's a wall, brick wall or concrete wall, like this, fence. So we have a different type of footing which called strip footing. Sometimes, for some reason, I cannot put my column at the center line of footing. So I will put the column at the edge. So I expect overturning of my footing, so I have to connect it with the other footing with beam called strap. So at this moment, your footing called strap footing. Most of the time, this happens at neighbors, beside neighbors. The next type of foundation, mat or raft, just only one footing for the whole column of your building. But this time we can call it footing, we call it raft or mat. We can call it mat. Looks like this, very, very big footing with double layer of steel reinforcement, all columns coming out from this raft. The last one, which called deep foundation, 100% of bridge, highway bridge, constructed using this type of foundation. Some 10%, 20%, 30% based on how many floors do you have. For building, we're using deep foundation piles based on what is the type of soil. Piles means you have embedded column in the soil. This column connected to footing, but at this time we can call it pile cap, and your pile cap connected to the column. The strategy for piles, here is the reaction of the column. This reaction will transfer to these piles. These piles embedded your soil in the soil to transfer load to very, very strong soil layer. Here is the shape. Construction of piles, something looks like this machine. You can make excavation until you reach the required depth, then get out this part and pour your concrete, and then put your steel reinforcement. This one type of construction. There is many other type. You can put some mud or something like this. Anyway, it's not our topic today. It's related to soil mechanics. We have also something called boring. You can get some samples from the different depth of layers inside the soil, and based on some lab test, you can determine something called bearing capacity. Bearing capacity, something looks like compressive strength of concrete FC prime. Last time you saw, if you have cylinder and apply compressive force, this concrete can support stress until maybe 6,000 psi. Okay, I have soil and I apply compression force. Can you tell me what is the strength, compressive strength of this soil? We can call it bearing capacity. At this type for soil, call it bearing capacity. Based on what is the type of your soil, I can expect the bearing capacity PSI, or pound per square feet. We started last time also design of footing. We have a building, and I think you are done with one floor. Your homework, you have a floor, one floor like this, and you already solve it using Reza floor. And you are able right now to get reaction on each column, I believe. Anybody tried to solve this floor using Reza floor? Homework, for homework.
Only the first one.
You are trying, still trying. Okay. Maybe more advanced level for this software, we can talk about it next semester during your capstone project. These types of software, there is a communication between them. You can solve your floor on Reza floor. You can export it to foundation to design your foundation. So there is a communication between each software and the other one to make the complete design of your building. Anyway, first step to design your footing, we are looking for this one. And remember, to design footing, we need to answer some question. First question, what is the depth? H footing. Second question, what is the dimension of your footing? L and B. Third question, how much steel reinforcement in both sides or in both directions for footing? If you answer this question, you are done with your design. Each footing, we need to answer this question. What is the depth? What is the dimensions? And how much steel reinforcement we need to use. First step, go ahead and calculate what is the surface reaction. Put it in your mind. The word surface means an factored load. That means your dead load plus live load without any factor. Second, we need to get the factored column load, the ultimate, which is 1.2 dead load plus 1.6 live load. Why we need both of them? We will use this one for one step and this one for another step. Next step, we need to determine the thickness of the footing. Your thickness equal depth plus cover. In foundation, you need to increase your cover to protect steel reinforcement from anything from the soil. So we are using 4-inch, maybe more, for cover. Your depth can be determined using this equation if your column is rectangular column. And put it in your mind, dimension of column called PB times C. B and C dimensions of the column. We remember and we learned design of column B and C. The minimum dimension. Anybody remember what is the minimum dimension? 8 to 10 inch. So maybe your column 12 inch times 30 inch. That means B equal 12, C equal 30. Anyway, D, your depth of footing, I'm looking for the D. B and C dimension of the column. D, I'm looking for D. B ultimate from the previous step. Phi for foundation equal 0.75. Mu C, I can get mu C from this equation, equal 4 lambda square root of FC prime, lambda equal 1 for normal concrete. But if your column is round column, circular column, we learned it before, sometimes your column may be circular with diameter D. At this moment, first get a factor A or get a dimension A equal square root by D squared divided 4, this is D capital, diameter of column. From A, I can put it here and solve for this equation to determine what is the depth of footing. Once you get your depth, go ahead and add 4 inch to get your HF, the total thickness of footing. Remember, please, it's recommended to make your total depth or total thickness multiples of 2, 4, 6, 8 integer and even number. Any questions so far? Any questions so far? So it's important or required, not important, required to design your column before starting to design foundation. Where is what is the next step? Next step, we need to determine something called Q net. Find net allowable soil pressure equal Q allowable minus HF times gamma C minus gamma soil. Gamma C, unit weight of concrete. Anybody remember how much? Gamma C for concrete? 150 pounds per cubic feet. Gamma soil, unit weight of soil. We did some excavation, so we need to determine what is the unit weight of this soil that was excavated. HF, you did it, the total thickness of footing. Q allowable, peering capacity. Peering capacity of soil. You should know what is this value by doing some experimental work on the soil. Once you determine Q net, one more time, gamma C, unit weight of concrete, 150, gamma soil, unit weight of soil. Q allowable is the bearing capacity of the soil. Once you get your Q net, go ahead and determine what is the area required of this footing. Area required, this area. The area of the footing equal B divide Q net. Anybody remember what is the value of B? We have two types of B. We have surface load and we have ultimate load. Which one I will use? The surface load. B dead plus B live without any factor will be used to determine your area of footing. B surface column reaction. without any factor, all and factored reaction, or dead load plus live load without any factor, divided by Q net. I can tell you what is the area required, this area. So we have two situations right now. Maybe your footing is a square footing, so this L equal to this one, so L square equal area required. If you would like to get one side of your footing, square root of area required. Or your footing is rectangular footing, so you have to assume one side and determine the other side by dividing area required by the assumed dimension. So for example, if your area required equal 25 feet square, I'm designing square footing. What is the dimension of footing? I'm designing rectangular footing, and I assume one side 4 feet. What will be the other side? Okay, area required 25 feet. So if you are designing a square, this length equals this one. So I will assume this one 5 feet and this one 5 feet. 5 times 5 equals 25 or greater. Maybe you can assume 5.5, or you can assume 6 times 6. That's fine. This is a minimum. Area required, you can exceed it as you like. If your footing is rectangular, I will assume one side and the other side will be 25 divided 4. You can get your dimension. Any questions so far? Anybody know why this load is unfactored load? What is the factor of safety? Why I didn't put factor of safety here? Because this one will divided by Q net. Q net related to bearing capacity. Bearing capacity from soil boring without any factor. So this one is coming to you without any factor. So I have to put B without